Okay, now let's start section 4.4, counting rules. We have factorial notation and then the combinations for this section. So now let's start with the factorial notation. So the factorial notation uses the exclamation point, and for any counting number n, we have n, and then use this exclamation point, and then we read this as factorial. So n factorial equals starting from the integer n times one less, which is n minus 1, and then up to down to 1. And then we have a special defined term, 0 factorial. We define that to be 1. Then let's do two examples. 9 factorial. So by this rule, represent 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's going to be a huge number. We can calculate that. And for 5 factorial equals 5 times 4 times 3 times 2 times 1. So this one is easier because we have 12 times 10, so that's 120. So that is 5 factorial and 9 factorial. Then let's look at combinations. A selection of distinct objects without regard to the order is called a combination. For example, we have 5 little balls in a bowl, and then always different colors. And then we want to see how many ways we can just select three balls from that bowl. So that is a selection of distinct objects without regards to the order, and then we call it combination. So the selecting process is one important part for combination. So we say the number of combinations of R objects selected from N objects is denoted by trues. So this capital letter C, we read it as trues. So trues from N, and then we want to choose R. So trues N R. So N is how many numbers we have. So R is the number we want to have. So this N is always going to be greater than or equals R. So it's going to be given below. So this combination calculation equals n factorial divided by n minus r factorial times r factorial. And then we have choose n from n, so just one way. And then choose r objects from n, we have the same as choose the other part. So for example, the 5 balls in a bowl case. So choose 3 equals just leave 2 there. So then choose 5 2 equals choose 5 3. So we can actually show this. Let's write down choose n minus r. So that is n factorial. So based on this rule, we can apply it. If this is r, then we have n minus r and then r factorial. If it's n minus r, then that's going to be n minus r factorial and then n minus r factorial. So n minus r. So if we break this brackets, then it's going to be plus r. So this is the same as r factorial. So r factorial n minus r factorial as the denominator, so they are the same. Now let's look at an example. The director of movies at the park must select 4 movies from a total of 10 movies to show on movie night at the park. How many different ways can a selection be made? So different ways, selection, so we don't really care about the order. Then let's see. So we can just use numerical value to represent 10 different movies. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 different values represent 10 movies. So we want to select 4 movies from a total of 10 movies. It could be 1, 2, 3, 4. It could be 1, 2, 3, 5. And then could be 1, 2, 3, 6. So we can always just write it down to look at how many different ways exactly. So we have 1, 2, 3, 4. That's one way to out of this 10 select 4 movies. 1, 2, 3, 5. 1, 2, 3, 6. 1, 2, 3, 7. 1, 2, 3, 8. 1, 2, 3, 9. 1, 2, 3, 10. So that's all for 1, 2, 3, and then we can have 1, 2, 4, 5, 1, 2, 4, 6, 1, 2, 4, 7, 1, 2, 4, 8, 1, 2, 4, 9, 1, 2, 4, 10. And then we have 1, 2, 5, 6, 1, 2, 5, 7, 1, 2, 5, 8, 1, 2, 5, 9, 1, 2, 5, 10. We can have 1, 2, 6, 7, 1, 2, 6, 8, 9, and 10. 1, 2, 6, 1, 2, 6, 1, 2, 7, 8, 1, 2, 7, 9, 1, 2, 7, 10, and 1, 2, 8, 9, 1, 2, 8, 10, and 10, and then we have 1, 2, 9, 10. That's all for 2, 1, 2, and then now we have 1, 3. Now we have 1, 3. So we have 1, 3, 4, 1, 3, 1, 3, 4, 5, 1, 3, 4, 6, 1, 3, 4, 7, 1, 3, 4, 8, 1, 3, 4, 9, 1, 3, 4, 10. So then we're gonna have 1, 3, 5, 6 to 1, 3, 5, 10. 1, 3, 6, 7 to 1, 3, 6, 10. So 1, 3, 6, 8, 1, 3, 6, 9, 1, 3, 6, 10. This is gonna be 7, 8, 7, 9, 7, 10. And then 1, 3, 8, 9, 1, 3, 8, 10, 1, 3, 9, 10. Okay, so that's all for 1, 3 something. And then we have 1, 4 something, 1, 5 something, 1, 6 something, and then so on and so forth. So we still need to have a lot to do, which is a long process, and that's why we need to learn this combination rule. So by the rule, we just need to calculate truths 4 from this 10 movies. And then we know for n choose r, we have n factorial divided by n minus r factorial and then r factorial. So this is going to be 10 factorial divided by n minus r, 10 minus 4, 6 factorial, and 4 factorial. So we just need to calculate this to get the different ways. So let's see. 10 times 9 times 8 times 7 times 6 factorial. That's 10 factorial, right? Because 6 times 5 times 2, 1, that's 6 factorial. So we can just write like this. Divided by 6 factorial and then 4 factorial. So we have 6 factorial both in denominator and a numerator, so cancels out. So now we just have 4 times 3 times 2 times 1 as the denominator. And then we can have 2 times 4, that is the same as 8, so cancels out, and then 3. So we got a 3 here. So we have nothing left for the denominator, and for numerator we have 3 times 7 times 10, so we have 210 different ways. 210 different ways. So if you want to list out, you have to list 210 different ways. And based on this method, if you just continue, make sure it's by order, you can count a total of 210 there. That's this example. Now let's look at another practice problem. This is for the whole chapter. So it involves a lot of concepts from different sections. So in the test of the allergic drug Saldane, the following result were collected. And then if one person is selected at random, we want to find out those probabilities. So this is given information. We have Saldane placebo control from one dimension, and from another direction we have headache, no headache. And then probability they took placebo. So this is basically using the F over N rule and then some other probability rules. So placebo, so we just need to have the count, the frequency for the who took the placebo. So the total count for people who took placebo is 665. And divided by total number, we have 272. That's the probability. So you can use your calculator, calculate that out, and write in decimals or percentage. And Saldane, same thing, right? We have 781 divided by total 2072. And placebo or Saldane, so we have an or problem. So based on the addition rule, so that is probability of placebo plus probability of Saldane minus probability of placebo and Saldane. So that is 665 divided by 2072 plus 781 divided by 2072 and minus. So we want to look at placebo and Saldane. Placebo and Saldane. So there's no overlap. So that is 0. And then the answer is gonna be 665 plus 781. So 1446 divided by 2072. For no headache, so no headache, the total count is 1950. So right here, 1950. 1950 divided by 2072. And Saldane and no headache. Saldane, so this column, no headache, this one. So this is the overlap. 732 divided by 2072. Or no headache. So Saldane or no headache, again, same rule, addition rules. Probability of Saldane plus probability of no headache minus probability of Saldane and no headache. So that's gonna be probability of Saldane 781 divided by 2072. plus probability of no headache 1950 divided by 2072, and then minus Selden and no headache 732 divided by 2072. So that's gonna be 781. This is 781. 781 plus 1950 minus 732. So that's 1999 divided by 2072. And then probability of Haldane given they took Selden. Probability of headache given Selden. That's gonna be the conditional probability. So probability of a headache and Selden divided by whatever you put in the condition given Selden. So that's probability of Selden. So we have headache and Selden, which is 49 divided by 2072, and divided by probability of Selden, which is 781 divided by 2072. So which is 49 divided by 781. So basically, a conditional probability is you just look at the condition column. So given they took Selden, then now our data set is only within this column. So all the rest, we don't look at those. Then you're gonna use the F over N rule. F gonna be headache, which is 49, and divided by the total. Now the only total we have is 781. So 49 divided by 781. So it's gonna be same as you directly use the formula. So a person did not take Selden. So this is the complementation rule. Equals 1 minus probability of Selden. So 1 minus 781 divided by 2072. Which is 1291 over 2072. Complementation rule. Okay, that's all for